Hi everyone, my name is Muhammad Haris Fahmi bin Muhammad Helmi. Alongside my group members Muhammad Hakimi bin Muhammad Hafiz and Muhammad Shukri Aiman bin Dawis, we present how to operate the solar-powered smart irrigation system in agriculture. So first, let me explain what is smart irrigation system. The smart irrigation system is a system that precisely apply water in the soil to help growing agriculture crops following the crop's precise water needs, using solar array to power the system, and using sensors such as pH sensors, temperature sensors, and soil moisture sensors, and also weather forecast to precisely calculate when to apply water into the soil and to calculate how much amount of water needed to apply to the soil. So, why did we come up with a smart irrigation system? Irrigating the soil manually can lead to water loss. It is because the calculation is made manually by hands and tools, which is time consuming and less precise, especially when managing big gardens. When it is less precise, the water amount sometimes can be less and can be too much for the crops. If it is too much, the pH of the soil will be acidic, which is not suitable to grow crops, and it leads to over-irrigation, which will cause the nutrient in the soil needed by the crops to be washed away, and also it will cause the crops to be suffocated. By using smart irrigation system, the water is applied precisely to the crop's needs and prevent water loss for about 30 to 40%. And it's also more time efficient and use less human energy to work. Next, we move on to the procedure of operating the solar powered irrigation system.
Alright, thank you Harid. And now I will continue the presentation with operational workflow of the Powered Solar Smart Irrigation System. The workflow is divided into 5 stages. First, the sensor and power deployment stage is carried out. In this stage, the solar power array is installed to provide a sustainable source of energy for the entire system. Soil moisture and nutrient sensors are positioned at appropriate locations across the field so that accurate data can be collected. And after the installation is completed, all key parameters are configured and the sensors are calibrated to ensure that reliable data and that reliable measurement are obtained. Next, wireless communication testing is performed. Wireless communication modules are installed and tested to verify that stable connectivity is established. In this, ensure that the data collected by the sensors are transmitted securely and accurately to the cloud platform. Through this process, continuous communication between the field devices and the monitoring system is maintained. And then data analysis and prediction are conducted. Real-time soil moisture and weather data are collected and uploaded to the cloud. These data are analyzed using cloud-based models and irrigation requirements predicted. Based on the analysis, dynamic irrigation schedules are generated so that water can be supplied only when it is needed. As a result, water conservation is achieved and crop growth is supported more effectively. And after that, the automated cycle and adjustment stage is implemented. Irrigation process is automatically initiated according to the recommendation generated from the data analysis. Water valves are calibrated and the system is monitored for pressure drops or flow restriction. If the adjustments are required, the watering duration is modified automatically to ensure that the appropriate amount of water is delivered to the crops. And finally, reporting and stockholders alerts are completed. Comprehensive reports are generated. To summarize, system performance, water usage, and sensor readings potential failures, and maintenance requirements are identified, and notification messages are sent to operators and stockholders through text message or email. In this way, calmly action can be taken whenever issues are detected. And that's it from me, and I will pass to Kim.
Okay, now I'm going to explain this safety precaution when operating a solar power irrigation system. Safety is a crucial aspect because this system combines electrical, mechanical, and water components which can pose risk if not handled properly. First, we must always wear personal protective equipment such as leather gloves, safety boots, and helmet. These items protect us from electrical shock, mechanical injuries, and falling objects. PPE is the first line of defense against unwanted hazards, and it ensures that workers can operate confidently and safely in the field. Second, proper installation is essential not only for maximizing performance but also for reducing risk. Solar panels, wiring, controller, and must be installed by certified technicians to ensure compliance with safety standards. A well-installed system minimizes the chances of electrical faults, overheating, or mechanical breakdowns. Third, you need to consider the weather condition. Since solar irrigation systems are exposed to the environment, sudden rain or storm can damage the electrical components. To prevent short circuits and equipment failure, all electrical parts should be housed in waterproof enclosure. This precaution ensures durability and reliability even under unpredictable weather. Fourth, regular inspection and maintenance are necessary. Cables should be checked for wear, corrosion, or rodent damage. Pumps and motors must be serviced periodically to maintain efficiency. By conducting routine inspection, we can detect problems early and prevent costly breakdowns.